Where's that? I forget, what's that?
16. Make sure you're asking, make sure you're following along so that we can get them done before start this quiz. Don't be afraid to ask either. 29. Seems like that's one that a lot of people want to see. So, problem 29 on page 6 or 17, 16, 17, whatever page it happens to be on. I don't have to go through that, do I? You guys know if I say page 16, it's all the problems on 17, 18, whatever it continues on to, right? Problem 29. Pick me a couple of these. I don't want to do all 4 of them really, but pick me like 2 letters. A and which ones? A and B. Is that the ones everybody wants me to do? Because I think some of them are different, aren't they? Which ones are different? Might want me to do a different one. We'll do A, then try to figure out if one of the other ones is different. On this, they tell us that point S is between R and T. Isn't that what it says? So when I draw this, I'm drawing my picture here. What point am I going to label this, or what letter? R. Where's S at? Now, when we say in the middle, what's that mean? So it's got to be right here?
No.
Does
It can be anywhere on that line in between.
All right, anywhere. So I wouldn't put it right in the middle, just because if you put it right in the middle, then what are you going to think? That it's half of it. It's a midpoint. And did they tell us that?
No.
Now, this is the way I do this. You don't have to do everything exactly the way I do it. I usually do something like this, just because this is the way I learned how to do it, and because I do a lot of woodworking and different stuff at my house. So when I want to show that from here to there is a certain thing, then I draw these little markings and then write whatever it is right there in the middle. All right? Maybe you don't want to do it that way. Mr. Woodall wants to do it some completely different way. That's fine as long as he understands it. All right? What did they tell us about segment RS looking at problem 29 on part A there? 2x plus 10. So watch what I'm going to write in here. 2x plus 10. That makes sense so far? That makes sense? Then I do the next one. What they tell us about segment ST. X minus 4. Everybody agree with that?
Yeah.
So I write it in there. Then they told us something else. I think they told us the whole thing, right? How long is segment RT? 21. Does that make sense so far? Yes, no, maybe? Now, we want to figure out how long each of these segments are. Well, one of them we know is 21, but the other 2 we don't know. We need to be able to set up an equation. Segment addition postulate says this segment, well, what is that segment? RS, tell me what they told us about it. It's 2x plus 10. So I'm going to write that down. Plus that segment, so plus x minus 4, should equal the whole thing, so equals 21. This plus this equals the whole thing. That makes sense? Yes, no, maybe? Craig, that makes sense? From algebra last year, you should be able to solve equations. 2x and x, they're on the same side. You just put them together. Don't do the opposite to get them together because they're on the same side of the equal sign. What is 2x plus x? 3x. So that takes care of those. What's a 10 and a negative 4 give us?
6.
Everybody agree with that? 6? So plus 6 equals, now what?
Minus 6 from both sides.
Make sure you're understanding as we're going through this. You're not stopping and say, hey, how'd you get that? It's not a big deal. Those cancel out. You're left with 3x equals 15.
Divide that by 3.
Mr. Yount, you might have to scoot that table that way. You'll probably be in Mr. Holster's way and stuff, but he'll get over it. You're more important than he is. That way, my fat body's not in your way the whole time. Divide by 3, x equals 5. In algebra last year, you probably finished right there, right? Is that where we're finished at? No. What'd they ask us? Go back and read the problem. What'd they ask us to find?
Length of RS or
Length of segment RS. Length of segment ST, is that right? And then length of segment RT. How are we going to do that once we know?
So then you're plugging in where X is.
Daniel, that makes sense what Maisel just said? You're going to plug it in. We know X is 5, so we're going to take it and we're going to plug it into that. So 2 in place of X, what do I stick in there? 5. What is 2 times 5? 10 plus 10? 20. How long is segment RS then? ST, we plug in 5 right here, so you got 5 minus 4, 1. Now look at my segment. Does it look anything like it probably should look? No. Because RS should be about this long and ST should be about this long. Does that really matter? No, we don't care. We weren't drawing the picture to make it look correct. We were drawing the picture so that we could use it to get the answer. All right? How long is segment RT? 21. How do you know that?
It's in the beginning of the problem.
They told us that, right? So if Austin misses that on the quiz, something's majorly wrong, right? Because they gave us that answer. Somebody figure out, was one of the other ones different?
D.
Which one?
D.
D. Is that the other one we want to do then for this part's D? Because I don't want to do all 3 of them, or all 4 of them. Yes? Letter D on, this is still problem 29, right? 29, is that right?
Yeah.
Somebody real quickly come up and draw, not our usual suspects here. Maisel, you're not allowed to volunteer for this because you volunteer all the time. I appreciate that, but I want somebody different. Give me somebody to go up there and just draw the segment for us. All you gotta do is draw the segment. Go ahead, Michael. Well, we're gonna put the letters on it too. Draw it with the actual pen so we can see it up there. What else does he need? Don't go away. The point, right? Now, don't say midpoint because we're sure it's a midpoint. No, we need some other point in there. Where's that other point gonna be at? Anywhere in there. Now let's put the letters on there. What letters has to be in the middle, or between, I should say? S, so let's put an S with that point. What's the other 2 letters? R and T. Put an R there, a T there. Michael put his letters above, is that all right?
Yeah.
Yeah, who cares? It doesn't make any difference whatsoever. Does that make any sense?
Yes.
Somebody help me out. How long did they tell us RS was? 4x minus 9, so watch. Michael draws his this way. Could he do something like this to show him that that's 4x minus 9 instead of doing it the way I did it a second ago?
Yeah.
I don't care how you do it as long as you understand what you're doing. That's all that matters. How about this segment? What'd they tell us about it? 19? And how about maybe Michael does something like this for the bottom one? Can you put that little crazy mouth looking thing on there to show that?
8x minus 14.
Minus 14. Ignore that crazy line that went off there. Segment addition postulate again. This segment plus that segment should equal the whole thing. What is this first segment?
4x minus 9.
Everybody understands that, not just Seth, right?
Yes.
Right? Plus, what's the other
8x
segment?
minus 14.
Be careful.
19.
Sure.
They changed it around on you, didn't they? They tried to confuse you. This plus this, well, how long is this part? 19. They tried to mess you up. And that should equal the whole thing. How long is the whole thing?
8x minus 14.
So you got to be careful and make sure you're setting them up correctly each time. What like terms do we have on the left?
9, 19, 9, 19.
What's that give you? Negative 9 and 19.
10.
10. So 4x plus 10 equals, any like terms on the other side? What I do now, here's where a common mistake occurs.
Subtract an x.
Subtract an x, which one?
4.
The 4x. The common mistake on this step right here, a lot of times students will get the numbers together instead of the variables first. Do the variables first, all right? And then the other common mistake, you always want to take the smaller x to the bigger x. You don't always just want to pull everything to the left, okay? That way you don't have to deal with the negative. Now, either one of those, does it really matter? No, you could do it in the other order. I just know what confuses a lot of you, and you get confused when you put the numbers together first, or when you take the bigger variable over to the smaller variable. That seems to confuse a lot of people. So here I want to subtract 4x on both sides. What's left on the left?
10 equals 4x.
Now we want to move the 14 to the other side. Those canceled out, equals 4x. Divide by 4. These cancel, and that leaves you with x there, equals what?
8.
8? 6?
6.
Which one is it?
6.
Is that our answer?
You said you put it in.
We want to find each of those segments again, right? Segment RS, segment ST, segment RT. Segment RS, we plug in right here. 4 times, what did we say x was? So 4 times 6 minus 9. Be nice maybe you have a calculator, right? So you don't have to make a mistake in your head. What's 4 times 6? 24 minus 9? 15. Everybody agree with that? ST, how are we going to find it?
19.
They told it to us, right? And how are we going to find segment RT?
8 times 6 minus 14.
You could do 8 times 6 minus 14. I think there's an easier way. Just add those two together, right? This plus this should equal the whole thing. What's 15 plus 19?
34.
34. Now you got to be careful because one of the problems on the quiz looks like this. I don't know what it is, but I'm just going to make up something here real quick. It looks like this, and it tells you this part right here is 3x minus 2. This part is 2x plus 5. Are we going to use this same method to solve for x and find those two segments there? What's these little tick marks tell us?
They're the same distance.
They're the same, right? They're equal. They're same length. Do I say this plus this equals the whole thing then? I don't know the whole thing, do I? What do I know about these two expressions? They're the same. So all I really have to do there is put an equal sign in between them, then solve that equation. So don't get that confused when they're talking about a midpoint. You might be setting up a different equation than when you're talking about segment addition. All right? Lots of different equations you're going to have to set up throughout the year, and you got to know, hey, when I'm doing this, this is the one I'm going to set up. When it's something different, I'm setting up something different. You got to be able to pick out what you're setting up different. Other questions on that page? If not, we'll jump. Oops, didn't mean to do that. If not, we'll jump to the next one. Any other questions on that page? Probably join us to see work. Don't be afraid to ask. Thirty-six. 36. Is the kind of problem you'll find on the end of year geometry test. It's not a hard problem. It's just something where you have to think it through yourself. Am I going to be able to show you every single kind of problem that they could put on there? Absolutely not. Because what they're going to do is they're going to say, okay, you learned this, you learned this, you learned this, and then they're going to put the three things together. You learned about a midpoint, you learned about segments, and then they're going to put it all together. Let's see on this one, what's the first piece of information that they told us? I don't think that's the first thing they told us, but we'll use it. AD was 12. What else did they tell us?
AB is congruent to BC.
So I'm going to mark that. Segment AB is congruent to segment BC. Does everybody understand that those tick marks mean that those two are the same? They're equal.
Yeah.
What else did they tell us?
AC is congruent to CD.
It's sort of hard to mark when you get this much stuff in here. So maybe I do something like this. This segment equal to that segment. Can I just put one tick mark on them?
Two.
Why not just one?
Because you already have one on there.
Or I have one. That makes it look like all four of these things are the same. So we want those to be different. So now we know that those two links are the same. These two links are the same. Again, if Michael over here doesn't like the way I marked it, can he mark it some completely different way problem?
Yes.
Make it so it makes sense to you. Somebody tell me, let's see, how many segments are there in this picture? Let's name all the segments in the picture.
AB,
AB I heard,
AC,
AD I heard, AC I heard, BC, CD, BD,
yep,
BA. Do we need BA? AB and BA, are those the same segments?
Yeah.
Yeah, we don't need both of them because they're going to be the same length. Is that all of them?
Yes.
So we're going to figure out what each one of those, what the length of each one of those is. This is something that's not hard. You just got to use your brain. You got to think things through and be able to think it through. What do we know about this whole segment, AD?
it's 12.
So let's write that in. We know that one. Anything else we know?
That AB and BC are the same.
A.
AC and CD are the
Go ahead,
same.
Michael. What did you start to say? AC is what?
AB and AC are AB and BC are
Right. So we know that. You started to say AC though. I thought you were going to.
AC and CD are congruent.
They're congruent. Well, what's that tell us? If that whole thing's 12, what's that tell us? They each got to be 6, right?
Yes.
So this has to be 6. This has to be 6. What two segments have to be 6?
AC and CD.
AC, CD. Ignore that crazy mark through there. So each of those has to be 6. If this segment right here is 6, from here to here, now what can you tell me about segment AB? It's 3. How about segment BC? Do we know? Oops, that's not BD, that's the wrong one, sorry. That's wrong. Do we know how long segment BD is?
9.
How'd you get 9?
Add AC plus 3. Add AC and CD.
Segment addition postulate, right?
Add BC and CD
If I'm starting here and I walk to here, how far did I walk? 3. Then I stop and take a break, and then I walk to here. How far total did I walk? 9. 3 plus 6. 3 plus 6, which is 9. Do we know all the segments?
Yeah.
Yes.
Now, somebody read the question to me, because I don't feel like going back and reading it. What did it ask us to do?
By the length of the segment to the diagram, suppose you choose one of the segments at random. What is the probability that the measure of the segment is greater than 3? Explain your reasoning.
All right, at some point in your mathematical career, you've dealt with probability, maybe not a whole lot, but a little bit. All right, simple probability we find by doing favorable outcomes over total outcomes. So if I wanted to pick a name at random that started with a B, somebody's first name in this classroom, how could I figure out how many total outcomes there are? Count all the people, right? That's the number that would go on the bottom. And then the favorable outcomes, everybody's first name starts with a B, hold your hand up. So how many favorable outcomes would there be? 0. So what's the chances, what's the probability of me picking a name that starts with a B out of that? 0 out of however many, 27 or however many people's in here. Here, favorable over total. We want the probability, that's what P stands for, probability, that we pick a number that's less than, is that what it said, less than 3? Oh, it said greater than 3. No wonder. We want the probability that a number is greater than 3. Alright? Is that greater than 3? No. Is that greater than 3?
Yes.
So that's a favorable outcome. How about that one?
Yes.
How about that one?
No.
This one?
Yes. Yes.
So how many favorable outcomes do we have?
4.
How many total outcomes were there?
6.
What's the probability that we pick a number greater than 3 then?
2/3.
4 out of 6, which will reduce down to 2/3. So if we were playing a game and I put all those numbers in a bowl and you had to draw, I win if you don't pick a number greater than 3. You win if you pick a number greater than 3. Who's going to win more times?
Us.
You. Right? Because you're going to win 2 out of every 3 times. How many times am I going to win? 1 out of every 3 times. So that was the answer to that one, 2/3. All right, flip to the other page. Questions on the other page. I highly suggest that real quick on that other page we find something that deals with midpoint formula and distance formula, and then maybe one other problem. So that we make sure that everybody understands the midpoint formula and distance formula.
38.
38. On 38, I'm drawing this grid just so that we can model what they're telling us on this grid. We're going to make your house right here. What's the coordinates of your house then? 0, 0. Wish they quit doing that. Ignore that crazy mark there. What they tell us about the school? 20 blocks east, 12 blocks south. Now, I go up here. If you ever look on a map, they got a little thing up at the top or off to the side somewhere. What's right here? N. What's down here? S. E. North, south, east, and west, right? So they said 40 blocks or 20 blocks east. So how far this way am I going to go? 20. And then what's it say? 12 south, right? So that's down here somewhere. What's the coordinates of the school then? How far out did we go? 20, negative 12 going down 12, right? The mall, what did they tell us about the mall? 10 blocks north, 7 blocks west. Which way is north going to be? So 10, and then west is going to be over here, right? So somewhere like in there, that's the mall. 10 blocks north, you gotta be careful here. 10 blocks north, is that our X or our Y?
What?
That's our Y, so that means we went up 10, but we gotta put the 10 as the second number. 7 blocks west, what's that gonna tell us about the X over here? It's a negative 7, very good. It's a negative 7. What they want us to do, find the distance from the mall to school, or school to mall. So we're finding this distance. Now watch, even if you didn't understand all that picture that I drew, can you still understand the distance formula that I'm getting ready to do?
Yeah.
Alright, this is the distance formula. I'm going to write it out here, then we're going to use it. Distance formula. X's go here, so x minus x. You're going to square that answer once you subtract them. Then you're going to add that to the y's, go here, subtract the y's, square that, you're going to add them together, take the square root, all that stuff. Whole bunch of math, it's not as near as hard as it looks. Usually when I'm doing distance formula, I draw the skeleton of that formula first, and then all I got to do is plug in the 4 numbers. Sorry. What's my x coordinates for the mall and the school?
20 and negative
7
1.
and 20, or 20 and negative 7. It doesn't matter which order you put them in there. Alright, so just put them in whichever order. I'm going to put negative 7 first and 20 second. That's our x's. What's our y coordinates? 10 and negative 12. So 10, negative 12. That's our y's. Might help Mr. Yount to put x above this one, y above that one, so that he can remember, hey, these go in the x spots, these go in the y spots. Now we do the math. Negative 7 and negative 20 give you how much?
27. Negative 27.
Negative 27. What happens here when you're minus and a negative?
You're adding.
Change it to both of them, just cancel them out. What's 10 plus 12? 22. Here's where you're going to need that calculator, right? What's negative 27 squared?
729.
729?
Right.
I'm going to do it over here because my pen keeps messing up. 729. What's 22 squared?
184.
484. Big numbers this time, right? That's why it's nice to have a calculator. Make sure you get one if you don't already have it. What are you going to do with those two? Add them together. Somebody help me out, add those together. 1213, everybody agree with that? Now is that our answer?
Now you got square root.
Now take the square root. One of the problems on there said what was the mistake that the person made that we did, and the problem or the mistake that they made was they didn't take the square root at the end, and that's a common mistake. I see students all the time leaving that big radical symbol off as they're going down doing their work, and then trying to remember it at the end, and that's fine. But you got to remember to take the square root at the end. What's the square root of 1213?
34.8.
About 34.8. Now that's 34.8 blocks. That's how far the school is from the mall, about 34.8 blocks. The problem asks us to do something after that though. Put it in miles. What'd they tell us about each one of these blocks?
0.1 mile.
So it's 0.1 miles. If I told you that each block was 2 feet, what would you do with that 2 feet? times it. Always do that. Think of something easier in your head, and then think, okay, if each block was 5 feet, how would I find out how much 34 blocks is? I times them, right? Now go back and take the harder numbers, the 0.1. Guess what you're going to have to do with that 0.1 then? Times it. It doesn't change the operation, just changes the number. So on your calculator, you need to take 34.8 times 0.1.
3.48.
3.48. What's that tell us? It's 3.48 miles. What's about 3.5 miles?
From the school to the mall.
So when you walk from the school to the mall, you're going to have to walk about 3.5 miles. Did they ask us anything else?
No, I think that's it.
That was it? All right. Now, they didn't ask us this, but I'm going to do it. Just so I can do a midpoint on this one. So I can show you the midpoint formula. Is your house the midpoint between the mall and the school?
Yeah.
We don't know, right? The midpoint formula looks like this. X plus X divided by 2, comma, Y plus Y divided by 2. You take your X coordinates, add them together, divide by 2. Take the Y coordinates, add them together, divide by 2. That gives you the midpoint. What are the X coordinates for the mall and the school?
-20.
All right, let me do this real quick.
20 and -7.
Does it matter which order they go in? No, it doesn't. It's not going to hurt anything if you turn them around. It makes no difference. I'm going to do this because I don't have room here. So -7, I'm just going to try to write it in there. Can you sort of see that that's blue -7?
Yeah.
What's the other X?
20.
Is that confusing everybody?
No.
That confusing you? Miranda, you sure? It's not confusing you that I wrote over the top of them like that? Our Y coordinates. What's one of the Y's? 10, -12. Don't make the midpoint formula harder than it is, because all you're going to do is add the X's and divide by 2. What's -7 plus 20? 13. What's 13 divided by 2?
6.5.
6.5 or 6.5, right? What's 10 plus a -12? Be careful.
-2.
-2 divided by 2?
-1.
-1. That's our midpoint. Is your house the midpoint? No, it's not anywhere close to it, is it? Yeah, it's probably midpoint. My picture is drawn right somewhere down in there. So to find the midpoint, you add the X's, divide by 2, add the Y's, divide by 2. That should be an easy formula. Midpoint formula is pretty easy. Distance formula takes a little more work. Other questions on that page, real quick. Cowell, everybody, you think everybody understands them all? Everybody's bored to death because this is so easy, right? Miranda, that help any? Are you lying to me just so I'll quit talking to you? You sure? All right. No other questions? We're ready.
Mhm.
Desiree, you understood all that? Weren't you not here last time?
Yeah, whatever.
You understand it because you just quit.
Yep.
So on this quiz, you'll be fine.
Promise.
I figured that. All right, what you're going to do, first of all, listen closely. You're going to get with a partner. But with this many people, notice right here, this is the key to all this. What's that say? You have 15 minutes. With this many people, when I tell you to get with the partner, if it takes 10 minutes for everybody to get with the partner, then how many more minutes are you going to have to do the quiz? 5. That's not going to work. So when you figure out your partner right now, you should be thinking about it. You're going to get there and you're going to do this, and each person has to have their own paper. Right? It's in your book. If the quiz is in your book, am I going to sit here and watch and make sure that Mr. Gardner isn't flipping back in his book and looking, how do I name a line again? No, I ain't paying no attention to that. So use your book. Flip back in there and see how to do it. Maybe use your notes. I think the book's easier. Maybe you think reading your notes is easier. All right? So find a partner. Do it very, very quickly. Everybody has to have a partner. And what's a partner mean? I know Miss Reich, she doesn't want a partner because she's her own island. Hurry. I never changed anything. Daniel, did you find one? You moving towards your partner? Just pull that desk up there. Miss Jones, you really don't have a partner? Ah. See, I was going to, no, grab, there ain't a desk somewhere close? Move over here, both of you. Put my chair back.
What time?
Let me rotate here in a minute. Just keep working. Because right now time hasn't really started yet. So what you're saying is she put like you put D or something because you like to be separate. Daniel, would you go back to that C4? Austin, you better help him. He's lost. He's wasting time. Miss Jones, do me a favor. I know you're hard at work. Grab like one of those chairs, and then you can come up here and sit at his little table when he gets back. Now, as you're doing this, because I don't want you to get too far ahead and then know that you messed up. Number one, you only got 15 minutes. So if you're messing around, you won't get finished. Number two, when you answer the first question, somebody give me one answer to the first question.
0.8.
Now, Maisel, say it again.
0.8.
Did everybody hear that? If you don't have that in totality, it's wrong. Does everybody understand that? So if you wrote this down on your paper, what do you know I'm doing to that answer? Marking it wrong. You got to have the symbols and the names. All right? Point doesn't have a symbol, so you just have to write out the name. Austin, did you hear all that?
I already know it.
All right. Just want to make sure you don't miss a bunch of points and then be all mad at me because I marked them wrong. I see this. last year when I seen those. And I tried to explain to people. Should be watching right now. Number one, I'm hoping not a whole lot of people had trouble with number one. It said name 4 points. Give me a point on here.
H.
H. A, I heard. F. L. Good enough. Does it matter which 4 you picked?
No.
No, but you had to write the word point in there. Number 2. Number 2 said name 3 points
Collinear.
that are collinear. Sorry, give me 1 second. I'm trying to get my ink color back. 3 points that are collinear. I might pick A, L, B. 3 points that are collinear. That just means points that are on the same line. Number 3. I don't remember what number 3 said. Somebody help me out. Name 2 lines. Well, first thing I know is if I'm going to name 2 lines, I need the symbols. Give me 1 line. HG, I heard. CD, I heard. Is that alright? Have those 2 lines. Did you have to have those 2 lines? No, there's a whole bunch of lines. How about this? Could I put that line?
Yes.
Yeah.
Yes, because everything.
Is it 2 points? Is it going to make a line?
Yeah.
Now, if the directions had said, listen closely, if the directions had said, name a line that's pictured in the diagram, then that wouldn't have worked. Did the directions say that? No, it just said name a line in this diagram. Well, is there some line that goes through A and K and looks like that? Hopefully a little straighter than mine, but. Number four said, what, name 3 points on the green plane or something?
No.
Oh, 3 points that are coplanar? All right, give me 3.
H.
H,
F.
A, F. Everybody agree with those 3?
Yep.
What plane are they in?
Green.
The green one? So those are 3 you had to pick?
No.
No. Could you have picked C, L, and K?
Yeah.
Yeah, they're all on that blue plane or purple plane. Number 5, what did it say? Name the green plane? Is that right?
Yeah.
Here's where you had to be careful. Did it say name it 2 ways or just no, just one?
The ciphers.
Here's where you got to be careful when you're naming this. How many letters to name a plane?
3.
3. 1 letter if they give you something in the corner, right? Did they give you something in the corner this time? So you can't name it that way. So you got to use 3 letters. What 3 letters? I heard H. I heard G. Be careful now. L. How come L, not F?
So it's not line.
All right. You can't pick 3 collinear points to name it. So H, G, L. Remember your 3 points when you're naming a plane? Maybe this would help. They should form a what? A triangle, not a line. Number 6. Name the blue plane in 2 different ways. Give me 3 letters that can name it.
CDK.
CDK will work. ABK, I heard. Are there many other ways that you could have named that blue plane?
Yes.
Yeah. Could you have named it ALB?
No.
No.
Again, because they are collinear. It's got to be 3 points not on the same line. Could be ALK. That would work. Number 7. Somebody help me out. What did number 7 say?
Name 3 line segments.
3 line segments. So I know I need these 3 symbols.
C and D.
CD. That's 1 segment. Ignore that. AL.
That's
DE. Does it matter which 2 points you picked? If I picked C and K, could that make a line segment? So as long as you pick letters that are on those 2 planes, can I really mark it wrong? No, the only way I'm going to mark it wrong is if you don't have that segment symbol. All right? Or if you, I guess maybe I would mark it wrong if you did something like this. If you had 3 letters, because how many letters to name a segment? Just 2. What's the last one say? Rays?
Yeah. 3.
3 rays? Give me a ray.
C.
Could I have just used the same as the segments up here and put a ray symbol instead? Yeah, don't make that harder than it is. All right? A lot of people still getting confused. Does DE have to be a segment? Does it have to start at D and go to E? No. Could it be a ray?
Yeah.
Could it be a line that goes out in both directions?
You're done.
Yeah, it's whatever you want it to be. You make that decision when you're answering the question. If they want a segment, then you say segment DE. If you want a ray, then you say ray DE. If you want a line, you say line DE, depending on what you're doing. Next one, number 9 said draw this. I'm just going to draw this picture real quick. We want to draw line QS. Several different ways you could have drew this. Don't worry that my points are look like they're above the line. They're supposed to be on the line. It's just horrible drawing. Now the thing that you could not do here, you got to draw ray QR. Can I start here and put QR out here?
No.
Because now I have what?
Array.
I have 2 Q's in the same picture. We don't want that. Where does this QR ray have to start at? At Q.
So it's opposite ray.
It could go out. Michael's saying take it out that way and put R out here somewhere. Would that work? Yeah. A lot of you probably did something like this. Would that work? Yeah. Many different ways you could do it. What do you do here to find the length of this whole segment? You get 39, is that right?
Yes.
How do you find this length from here to there? 62 minus 11, what do you get? 51. I've been yelling at you to put your units on stuff. Were there any units on either one of those problems? Next one. We want to do the distance formula and we want to do the midpoint formula for each one of these. I put a graph on my thing up here. Some people like to be able to see it. All right, there's graph paper up here. You can always grab it. Graph everything if you need to, if it helps you to see it. It doesn't help me to see it because I know just to use the formulas. So first thing I'm going to do, I'm going to find the midpoint because I know that's easy. For the midpoint, I know this is a 2, that's a 2 there all the time. You're dividing by 2. What's the x coordinates?
2 and 4.
4 and 2, 2 and 4, either way, it doesn't matter. What's the y coordinates? Negative 3 and 3. Again, it doesn't matter which order. What's 4 plus 2? 6. 6 divided by 2?
3.
What's negative 3 plus 3?
0.
Plus, or divided by 2?
0.
Now watch. A lot of people do this. When you're getting those 2 answers, I see people writing it as a fraction. It's a point, all right? X coordinate, y coordinate. Don't get them mixed up and write it as a fraction. That's what we're finding on that one. So that's your midpoint. Now the distance formula to find the length of that segment. I'm going to use that big long formula. I don't have it written up here anymore, but it just looks like this. What's the x coordinates? 4 minus 2. What's the y coordinates? 3 and negative 3. Make sure you're watching. These are the ones that a lot of you have trouble with. What is 4 minus 2? Maisel's going to make sure she's watching because I'm getting ready to show her something. So she's not sitting back there just talking to Miles. What's 4 minus 2? 2. What happens right here? What's 3 plus 3?
6.
What is 2 squared?
4.
4. What's 6 squared? 36. Now, when you get to this step right here, everything should be positive. If you still have negatives underneath that radical at this point, this third step in the process, you've messed up somewhere. Right? And what happens there is if I grab my calculator and I punch this in, negative 5 squared. It looks like that on my calculator. Does anybody know what the calculator is going to do?
It's going to just tack on the negative after you square it.
It squares the 5 and then makes your answer a negative. If you're going to punch all this into your calculator, then the way you need to punch that in, put parentheses around that. And then the calculator will understand. All right? What I'm hoping is that you remember what's a negative 5 squared mean.
Make it positive.
It's a negative 5 times a,
-5.
and what's a negative times a negative always?
Positive.
Positive. So when you get to this point right here, everything should be positive. What's 4 plus 36? 40. Somebody help me out. What's the square root of 40?
6 point.
Was it 6.3? Is that about right?
Yeah.
So that's the length of the segment. Midpoint of the segment, length of the segment. Next one. Let's try to do midpoint sort of in our head here without doing all that. What's negative 4 plus 5? 1. What's 1 divided by 2? 0.5 or 1/2. What's 5 plus a negative 3? 2 divided by 2?
1.
That's the midpoint. Distance formula. Sorry, I can't do the distance formula in my head. Michael probably can, but I can't. What's our x coordinates this time? Negative 4 or 5. You gotta write this out step by step. If we're actually doing a test on this quiz, it won't work this way. But if we're doing a test and you have this written down, if we're on a test and you have that much written down, I'll give you a point. You wrote the formula and you plug those numbers in, you get a point. Probably this problem would be worth 3 or 4 points. So you get a point just for being able to stick the x's and y's in where they belong. Right? Then we go to the next step. What's negative 4 minus 5? Be careful. Negative 9. Here's where Maisel was having trouble. She cancel these. What's 5 plus 3? 8. You plug that into your calculator. Negative 9 squared without the parentheses. It's going to tell you negative 81. Right? It should be a positive 81. Stupid thing. What's 8 squared? 64. Add those together, you get square root of something like 145.
And then it's 12.04.
What's that close to?
12.
12. Right? So we know even if you don't have a calculator, your answer should be somewhere close to 12. 12.0. That's how long that segment is. Don't put everything up yet. 18. What was the bisector? M. Point M, thank you. That's one worth a point. Now the other thing to find our S. This one's a little confusing. It's not the segment addition one. We're not saying this plus this equals the whole thing because they didn't tell us the whole thing. What's these tick marks tell us about these two? So all you're going to do to set up your equation, 6x minus 2 equals 3x plus 7. Anybody remember what x was?
3.
Yeah.
Once you know x is 3, what do you do with it?
6 times 3 minus 2.
Plug it in right there. 6 times 3 is what? 18 minus 2?
16.
How long is RM then?
16.
How long is MS?
16.
We wanted the whole thing, so what do we do with those two? Now we add them and you get what? 32. Next one. On this, I'm not going to do this whole problem because I know I don't have time, but on a baseball or softball field, is the pitcher's mound actually the midpoint between first or home plate and second base?
No.
No, it's not actually the midpoint. So this problem was a little wrong. If you did this problem, does anybody know the distance on a baseball field, the distance from home to second?
121 feet.
About 128 feet. How far would the pitcher's mound be then on theirs if it was a midpoint? 64 feet. All right? If it was a midpoint. Does anybody know what the actual pitcher's mound is on a baseball field? 60.5, 60 feet, 6 inches. All right? So this was a little off, but